So hello, welcome you all to this fourth session in numerical methods. This is a live session conducted especially for a problem solving related to numerical methods, and I am your teaching assistant for this course. Uh, till now we saw session 1 we started with introduction, error analysis and everything. Then in session 2 and session 3 were about linear equations, and now we have reached to the non-linear equations. So before going, I'll just introduce myself. I'm PhD student at IIT Guwahati and working in the field of lithium and batteries, and have been using these techniques to solve the mathematical models for my lithium and battery simulations. So with that knowledge, I am just trying to help you guys here if you have any doubts. So if you have any doubts, you can always put your doubts in the Google forum. So if you go into your Swayam portal, in Swayam portal there will be one link in announcement section, or you can go, there will be one link to, at the end there will be one link on the left hand side for a Google forum where you can put your doubt. So if you are solving some numerical or something and you found out to be okay, I don't know how to proceed or something, or even in lecture you find any difficulty understanding, you can put your doubts there. It's always better you put doubt there than then I can discuss it here in more lengthy manner, or otherwise I can reply you directly there also. And in terms of logistics, other thing is there is a problem solving session tab. So if you see, there is a week 1, week 2, week 3, and at the end there is a problem solving session tab. If you go inside it, you will find one spreadsheet or Excel sheet, Google sheet. In that there is a link for every session that happens. So within a one day I'll be uploading it on my YouTube channel, and that link would be provided to you. Also, the what is happening in the lecture class, these classes, all the writing what I'm doing right now, and the slides will be provided in the Google folder, like Drive folder. So if you miss this thing, or if you have any problem grasping at a first go, you can again go in there and check for yourself. So with that, let's start today's session. So in this session we started with the nonlinear equation, and in the nonlinear equations we are right now just focusing on a single variable. So can anybody tell me what is a nonlinear equation and how is it different from the linear equation that we were studying? So it's y is equal to 3x plus 9 x square. Is it a nonlinear equation? It's a nonlinear equation because of this square term for the dependent variable. So for a dependent variable, if the variable here only one variable is there, that is a dependent variable, single variable, for that if you are considering, then there is a nonlinearity involved. So with the linear equation, one good thing was the solution was finite. So if you had two lines intersecting, there is only one solution that is possible. Okay, but with the nonlinear equation, let's say this is x and y axis, and equation goes like this. The function goes like this. So there are three solutions to these equations, right? So there is not always there is a one equation. There are infinite number of solutions that are possible. So this is how we will. So how to solve these nonlinear equations we saw in the classes that were concluded in this week. So there are two methods. One, there are bracketing method, bisection and Regula-Falsi. So bracketing method is what? Let's say okay. So what we will do is, we will start with some initial guess. So there will be some initial guess, so this is your true solution. So we'll start some with initial guess. So from physics of the problem, from the understanding of the problem that you have first, so whatever equation you are written, you might be knowing what will the range of the solution. You don't know, you want to find the exact solution, but you know the in what range it might be. So we'll start with this premise, and why it is a bracketing as the solution, the guesses are considered such that they bracket this thing. Okay, so the actual solution and the initial guess bracket the actual solution. So that is why it is called as a bracketing method. And how to solve this, we'll see from the numerical. Even in Regula-Falsi method is a bracketing method. So they differ from the situation. To solve a nonlinear equation, there are basically three things has to do. First, you should have some initial guess. So that's what I told, XL and XR. Second, there should be some strategy to reach the next iteration. So what is the strategy? So it is the formula. So what is your formula for a bisection method? In a bisection method, from the name itself, it is an average. So we take an average of it. So XL plus XR divided by 2. So this is for a bisection method. And then you have this Regula-Falsi. So Regula-Falsi, in Regula-Falsi we consider a line. So in bisection what we do, we this XL plus XR divided by 2 to it might somewhere here, or it might come here also. In this thing what we do, in Regula-Falsi we we take these points, we join the line passing through this, and then from that we write an equation of this line, and from the equation of the line we try to find where it is cutting the solution. So that equation of line is there in Regula-Falsi, and that is how it is given. XL, so this is xi plus 1 is equal to x plus xr. Here xi plus 1 is next iteration. XL is equal to XL plus FL into XL minus XR divided by FL minus FR. So this is your XFL and this is your FR. So it is just the equation of line, rearranging it to find this xi plus 1. Okay, so these are your strategy that you will utilize. It depends on which strategy you are using, Regula-Falsi or bisection method. And in the third one, the stopping criteria. So last is the stopping criteria that you will define from the physics of your problem. So let's say you are interested in a very high accuracy, then you might go to the error less than 10 raised to minus 3, or it can also be written as 0.1%. So 0.1% is nothing but a 10 raised to minus 3 error. So otherwise you can say, so your accuracy till 4th decimal or something. So these all will give you the stop. This is the stopping criteria. So you will find an error after each iteration. So this is iterative technique, not a direct method. So after each iteration, you will find what is your error. So here we are considering the absolute error. So absolute error would be x I plus 1 minus x. Okay. So we'll see how to solve. And in the secant method, what happens is we don't consider this bracketing. So what we started with the premise that these two solutions might be at the different sides of this actual solution, this initial guesses, and then how we kept it inside, how we ensured that this actual solution is bracketing the method is by having one criteria that FL into Fi plus 1, and we found its value and checked if it is less than 0 or greater than 0. If less than 0, we replace the XR. If greater than 0, we replace the XL. Okay. So by that, what happened is always whatever your XL or XR you are choosing, that always was bracketing your actual solution. But in the case of secant, it is exactly as similar to Regula-Falsi method. Your formula, this strategy remains the same. This formula remains the same. Rather than calling it as XFL and R, we actually call this as a XI minus 1, XI, and this is a XI plus 1. Okay. So this would be your, so I'll write in a different color so it will be better for you if you come to this. Okay. So in Regula-Falsi, this point only will call it Xi minus 1, this is Xi plus 1, and this is Xi. So according to this will become Fi minus 1, Fi minus 1, and this is Fi, and accordingly for secant method this equation becomes Xi plus 1 is equal to Xi plus Fi into Xi minus 1 upon Fi minus 1. Okay, so the equation stays the same. So because of, so what will happen, whatever answer you will get, you will not check for this criteria, so you will always choose the current iteration. So this might be lot of theory for you and lot of jargon in the way I'm telling you. So better we will solve the problem, by that it will be more clear to you. So this is the first question. Let us consider the problem of obtaining the solution of the f of x is equal to 0. So we want to find the f of x for solution of x. With the fx is given as this, find the x after fourth iteration using bisection method. And we have given this XL and XR. So how you should start with this? Can anybody say something? Fox x is given a raised to x minus x square. It's better if you speak up, like this is a live session, I am not the professor, so it's better you speak up and then we will be better for all of us, right? Ganesham, you don't have the mic on? Hello? Oh, okay, fine. It's okay. So I'll just go through it. First, what we will do? So it's by bisection method, right? So what is the formula of bisection method? The strategy is xi plus 1 is equal to xl plus xr divided by 2. Okay, so for iteration 1, what they have given, xl is equal to minus 1, xr is equal to 0. Okay, so what you will find, so we have to come in this, what I told you, you have to compare this FL and FI plus 1. So we first have to find FL and fi plus 1. To find fl, you already have xl, so fl can be directly found out. But to find out fi plus 1, you don't have the xi plus 1, right? So first you will find out xi plus 1. So xi plus 1 is nothing but, so the first iteration is the, so I is 0 here, right? So x1 is equal to what? xl plus xr divided by 2, that is minus 1 plus 0 divided by 2, that is minus 0.5. Okay. Now you have these two things, fl and fi plus, you can find out these both things, fl and fi plus 1. So what is fl would be e raised to minus 1 minus x square, right? E raised to x minus x square. So e raised to minus 1 raised to minus 1 bracket square. So e raised to 1 minus 1, which is minus 0.6321. This is your fl. Okay. Now fi plus 1, that is, in this case I is 0, so f1. So what is f1? You just have to put this 0.5 value in this minus 0.5 value in the function, that is this function. So minus e raised to minus 0.5, right? So e raised to minus 0.5 minus 0.5 square. So how much is it? Yeah, so minus 898. Okay, so this is, so this is your f1. Okay, so this is a bisection method now, right? So in bisection method we want to have the bracket, that is the xl, for the next iteration whatever the xl value we are going to choose, that should bracket your solution. So ensure that we will check one thing, we will find what is fl into fi plus 1, that is fl into, in this case, f1. So this value is your positive here, sorry, you will have a positive or negative value. This is negative, this is negative, positive value, right? So this is a positive value. Since this is a positive value, what we will do, what I have written here, if the positive value reflects xl, since positive, xl is replaced in next iteration. So iteration 2, your xl value would be, so what to xl to replace with? Xl is replaced with your this value x1. So xl would be minus 0.5 and xr stays the same, 0. So try solving the second step. So what you will do after this? Excel, x2 is minus 0.25. Okay. And then now what you will do? Are you sure? Let me grab my calculator here. I guess you have given me the wrong value of fi plus 1. Check your this value. Yes. So this is positive, right? So this is positive. It means this will be negative. Since this will be negative, what will happen? This is negative. XR is replaced with X1. So XL will be similar, minus 1, XR would be sorry, 0.5, minus 0.5. Therefore, what will be X2? X2 would be minus 1 minus 0.5 divided by 2, that is minus 0.75. Therefore, f of x2, that is how much f of x2 would be? Minus 0.0901. And f of L would be similar, right? F of minus 1. F of L will not change. Okay. Always remember, in bracketing method we are multiplying with FL only for this this Regula-Falsi method. This bisection method. So there is no, you don't have to compute FR here. Minus 1 would be minus 0.6321. Therefore, FL into F2 is negative with positive, implies XL is replaced with X1, sorry, X2. Right? Iteration 3, XL is equal to, you have to change minus 0.75 and XR would be same 0.5. Therefore, X3 would be minus 0.75 minus 0.5 divided by 2. Minus 0.625. Therefore, what will be f of x3? First we will have to find f of x3, it is f3 we are saying, e raised to 0.625 minus 0.625 bracket square. Okay, correct. Therefore f of L is f of minus 0.75 that you have must have calculated na, minus 0.75, yeah, this minus 0.0901 इधर क्या होगा FL into Fi minus 1, yeah, we have already calculated in the previous iteration, right? Here this will not change. So this is if 3 is negative into positive would be negative. Negative means we'll have to change the XR with X3 in next iteration. Yeah. So you get the gist of it, how to proceed this, right? So you will have to iterate it one more time. Iterate it one more time to get the value of this thing. What I was saying, get the value, final value, because the question itself asks you to solve till 4th iteration. So to just demonstrate you how to, so this is how you solve by hand. I'll just demonstrate it in a better way so that you will have a better feel of it. So we'll just see how it is in your using Excel sheet. So let me just share my Excel with you. So this is a bisection method. So we started with this. If you can check your solutions, this is the one we started with, minus 1 in 0 here, right? And then this FL first we calculated this xi plus 1, that is minus 0.5. From that we calculated this fi plus 1, that is f1, and then we multiplied this and we got this negative value. Since the value was negative, we replaced XR in the next iteration. Okay, and then the similar thing with this XR value and XL value, we'll calculated this XI plus 1 here. With XI plus 1, put it into the equation, so we can get the value of the function. With the function value, and then calculating the multiplying with the FL value, you got this positive. Since this is a positive, this Fi plus 1, this xi plus 1 would go at XL rather than XR. So this is how we concluded and we got till here, right? So if you, for each iteration, you can find the error. So error is nothing but, so what is error? Error is mod of your starting value, that your this value, sorry, so mod of this x1 with XL. So we are comparing with the XL only. So for each iteration you get the value of x1, right? You compare it with the XL and you will find what is the error. So if you can see, error is going half after each iteration. 0.5, 0.2, 0.5, half of it is here. Because we are actually doing an averaging at a half, so error will always go half in that manner itself. So, and also this thing is also going, right? So here if you see at the error 10, so if we say that go for a error less than 10 raised to minus 3, so you could have stopped it here also. 10 raised to minus 3 means you have to go till here. Fourth error accuracy means also you have to go till here, and even there 10 raised to or 0.1% accuracy or 0.1% error is also here. So you will take this value xi minus 1, this value, as your solution. So this is how you find your solution using bisection method. Cool. So are they matching up the answers, right? So we'll go for the next method using Regula-Falsi for a next question. Okay. So in the problem, what they ask you, exactly. They asked you the fourth iteration, na? So this was your answer. Points minus 0.6875. Okay. Then let's go for this thing. Next solution, next question. So what is the next question? Next question is, for the fx is equal to, in the Q1, find the value of x after third iteration using Regula-Falsi method. Use the same initial cases. How to go about this? So there is a first thing is your initial guess. First is your initial guess. Second is your strategy for Regula-Falsi. So what is the strategy here? So this is initial guess xl comma xr. These are your initial guesses. Strategy is what? xi plus 1 is equal to xl minus xr divided by fl minus fr. Okay. And then here third iteration is told, so that is your stopping criteria. So you just have to find x3 here. Okay, so we'll start. So for iteration 1, xl is what? Same initial guess, right? So minus 1 and 0. Yes, you have any doubt, you can just post it. Yeah, multiplied by FL, right? I missed FL or what? Oh yes, here multiplied by FL. So I must have written, yeah, here I had written multiplied by FL. Thank you. Thank you for correcting me. XL for the first, the XL values are same, that is minus 1, and XR is 0, right? Just confirm, yeah, XL minus 1, XR is 0. Therefore, so here in the previous iteration, in the bisection method, you need not calculate this FR value, but here you have to calculate FR, FL, and that's it. Yeah, and to compare, you have to again calculate the Fi plus 1. So you need FL, FR, and Fi plus 1. So first we will find out Xi plus 1, that will give you this. FR and XL, XR and XL is with you, that can give you this XL and FL and FR. So what is your FL? Would be e raised to minus 1 minus 1 raised to 2. So that we already found out. This will be same, right? Minus 0.632. Minus 0.6321. FR would be e raised to 0 minus 0, that is 1. Therefore x1 I plus 1. So here I is equal to 0 for first iteration. So x1 would be this thing, xl, right? Xl is what? Minus 1 minus fl minus 0.6321 into xl is minus 1 minus 0 divided by minus 0.6321 minus 1, right? So what will be the value? It will be 0.6127. Okay, so now to do the bracketing, we have to check this, right? FL into Fi plus 1 is equal to what? We have to check negative or positive or negative. So FL, first FL we just have to find out Fi plus 1, that is F1, that is f of x1. So f of minus 6127. E raised to minus 0.6127 minus 0.6127 square. So f1 would be .1664, and this is your FL. So negative into positive, therefore FL into F1 is negative, implies XR should be replaced with X1. XL remains the same. So for second iteration, XL is equal to minus 1, XR would be minus 6127, right? Therefore that's the same. First we will find out FL, that is f of minus 1, it will be same, minus 0.6321. F of R is f of 6127, right? E raised to 6127 minus that you have calculated here. So it is equal to 0.1664 of R. Okay. Therefore, you have FL, you have FR. So now you can find out X2. X2 is XL, right? XL is minus 1. XL minus FL into FL is minus 6.321. Sorry. 321 into XL minus XR, minus 1 minus 0.6127 divided by FL minus FR, right? Minus 0.6321 minus 0.1664. So X of 2 would be minus 0.6934. So what will be your conclusion? FL into x2 FL into, so we still have to find f2, right? So f2 we didn't find. So f2 would be e raised to f2 into f of L. F of L is what? Negative. This is positive. This is negative. Implies, so this was positive. This is negative. Let's XR is replaced with X2 for a next iteration. So for iteration 3, for iteration 3 what you will do, XL again would be same, minus 1, XR would be minus 6.9.6934. Therefore, f of L is equal to f of minus 1 will not change, minus 16321, right? F of R e raised to minus 0.6934 minus R is equal to 0.18, sorry, 0189. Right? Therefore, now f in this formula FL, so what is the formula you have? XL minus FL, XL minus XR divided by FL minus FR, right? You have FL, XL, XR, FL, FL. These all are there. You can find XI plus 1, that is X3 here, right? So X3 would be, XL is minus 1 minus FL 0.6321 into XL is minus 1 plus 0.6934 divided by FL is minus 0.6321 minus FR 0.0189. x3 would be Are you following, Ghanasham? Ghanasham? Okay. So, yeah. Yeah. So, this is minus 0.7023. So, this x3 and your what? FL is positive and negative again. Therefore, FL into F3 is going to be negative. Since negative, again in next iteration, XR is replaced with X3. So can you just see here in this method, because of the nature of the problem, the XL is always being paused. Iteration 4. So we did not go to iteration 4 because they asked you to calculate till iteration 3 only, right? So after iteration 3, x3 value is your 7 minus 0.7023. But this is not your final solution. So I'll just show you the solution here. So you were able to see my screen, right? So in that, this was your final solution minus 703. So in the bisection method, your actual solution was minus 0.703 with decimal 10 raised to minus 5 less than 10 raised to minus 3 error. But at the fourth iteration, it was a far away from the actual solution. But in your this thing, in Regula-Falsi, in your third solution, it is near to this minus 703, right? So we'll see in Regula-Falsi, the error. So if you see here, so what this? So in Regula-Falsi, the error is still very high, but in terms of this is 7.03. So if you extend it, always the minus 1 is remaining here, right? And now this F1 is actually very much 0. So you can be contained with minus 0.703. It is not even changing. So you have already got the answer in your fourth iteration itself, or a third iteration itself here. So this was the one way, regular and bisection methods. Now we'll see the third method, that is your method that is not a bracketing method, that is secant method, right? So what is the difference in secant method? I told you, in secant method we are not bothered with keeping the solution, keeping the these guess values at, in the bracket to the actual solution. We can take any initial guess values, and that initial guess value may be on the one side of the actual solution, or the left hand side of the actual solution, the right side of the actual solution. It need not bracket. So here, because there is no bracketing required, we will not check, no check of this FL into Fi plus 1 for sign. We will not check the signs of it. What we'll do instead is, whatever the value which is the latest one, we'll consider that. So we'll see how to do that. So here, solution secant method, right? So secant method, xi plus 1 is how it is given, xi minus fi into xi minus 1 divided by fi minus 1. So x of minus 1 is not, so for a first iteration 1, it is I is equal to 0. So xi minus 1 is x minus 1, that is minus 1. So it's better if you write in x0 first, so that is equivalent to your xl, so you will not have any confusion. So x I is equal to x0, it is minus 0.5. So why I wrote it like this, because your Regula-Falsi is xl minus fl, right? And xl minus xr divided by fl minus fr. So if you L you substitute with I, and R if you substitute with I minus 1, you will get this. Xi minus 1 is x of minus 1, that's it, minus 1. Okay, so now you can directly find xi plus 1. Xi plus 1 is nothing but x1. x1 is equal to x of 0 minus f of 0, x of minus 1, sorry, x of 0 minus x of minus 1 divided by f of 0 minus f of minus 1. X of 0 is minus 0.5 minus f of 0. So yeah, we didn't find f of 0 and all those things, right? So first we'll have to find f of 0. F of 0, that is f of minus 0.5. So e raised to minus 0.5 minus 0.5 square. This we had calculated somewhere. F of minus 0.5, this minus 1.898. Right? That he had given me the wrong one, that one only, 0.3565. So, and if this f minus 1 you will require, right? F minus 1, f of minus 1 is minus 1 only. E raised to minus 1 minus 1 square. Minus 0.6321. So you have these values 0.3565 into x0 is minus 0.5 plus 1 divided by f0 is 0.3565 minus, so this will be plus 0.6321. So this is your, what is the value? Minus 0.6803. This is your x1. So now for the next iteration, what you will do? So for next iteration, you are not checking any values. What you will do is, this was I minus 1, this was I, and this was I plus 1, right? Now for a next iteration 2, this will be your I minus, this will be your I, and this will be I minus 1. This will be your I minus 1. So x of 1 would be minus 0.6833. This is nothing but x of I, right? And x of I minus 1, that is nothing but, sorry, this will be x of 0. This is x of I minus 1, and this is x of so for this condition I is equal to 1. If you put I is equal to 1 here, this is your x1, and if you put I is equal to 1 here, x of 0 would you consider at here. So you will always discard the most you will always consider the most latest value, and you will discard what is the earliest value. So the previous values you will discard, and earlier latest values you will consider. For with this thing you can calculate again xi plus 2, that is x2 is equal to x1 minus f1 into x1 minus x0 divided by f1 minus f0. Now you already have this this value, right? F of 0 minus 0.5. So you already have this, you already have this. Okay, you just have to and you already have this value, and this value also. You just already want to calculate this value here. Rest of the values you already have. So therefore f1 is f of minus 0.6833. That is e raised to minus 0.6833 minus 0.6833 square. right? How much is it? E raised to minus 0.6833 minus 0.6. How much? This is 0.3, right? This value only we are considering here. This is 6803. Point 43043.6. Therefore, x of 2 would be, x1 is minus 0.6803 minus, this is f1, 0.0436 into x1 is minus 0.6803 minus x of z, x1 is this, x0 is minus 0.5, that is plus 0.5 divided by f1 is 0.0436 minus f0, f0 is here 0.3565. Therefore, x of 2 would be how much would be x of 2? Yeah, minus 0.7054. Okay. So what will be error here in the first case? Error or E1 would be mod of, there we are considering XL, right? So I told you what is equivalent of XL? I. So this one you will consider minus 0.5 minus 0.6803, 0.18031. This is your error. Similarly, error 2 or EU2 would be x1 minus x0, yes, x1 minus x2. Point 0.251. So we are considering absolute error only, okay? Similarly, iteration 3. So iteration 3 is pretty straightforward now. What will be your x2? You will consider x2, x3 you have to find, x1 and x2 only you will consider, okay? x2 is nothing but minus 0.7054, x1 is nothing but minus 0.6803. Therefore x3 is equal to x2 minus f2. So this is everything, x2 minus f2 into x2 minus x1 divided by f2 minus f1. Okay, we have to find f2 first. So f2 is nothing but f of minus 0.7054. Okay, so e raised to minus 0.07, 0.7054. Minus 0.7054 square. Yeah, correct. So you have all the values, you can calculate now. 7054 minus 0.00367 x2 minus 0.7054 minus 3 divided by f2 is f1 you might have calculated f1 6803 0.0436. Therefore x of 3 is minus 7034. Correct? So this is what your secant method is. So we'll first solve one numerical again related to Regula-Falsi, but this time rather than being in the x1, it has given you some actual physical problem and is trying to tell you how to solve it. So we'll first see this and then we'll go to the Excel sheet and we'll see how the values differ and all. Okay, so you must have seen what is a Regula-Falsi. So first, what you have to do here, so for Regula-Falsi, or let's say any method, what you will do first, you will first find a closed form solution in terms of, so here what is the equation, the velocity v of a falling parachutist is given by this equation, where G is given to you. For the particles with a drag coefficient of C, so C is given to you. Compute the mass M so that velocity V is also given to you and at a time t. So in this equation, if you see, you know the value of V, you know the value of G, you know the value of C, and you know the value of T. So only unknown here is M, right? So you have to find that. Okay. So this is nonlinear equation. Why nonlinear? Because this M term, dependent term, is in the exponential. That is why nonlinear equation, and only one unknown variable is there. That is why nonlinear equation is single variable. Okay. So what we are doing, we were using fx is equal to 0. So first we have to get the form fm is equal to 0, and this xl and xr are value nothing but for your ml and mr, or better what we will do, we will write in terms of x only. So first what we will do, from given equation v is equal to gm minus c to 1 minus e raised to c by m into t, right? So therefore fm is equal to 0 implies we will take v on that side. So nothing but fm is equal to gm divided by c into 1 minus e raised to c by m into t, minus v is equal to 0. This is your fm is equal to 0. So everything is in terms of m. So we'll put the values, then you will get that. So 9.81 m divided by 15, right? 1 minus e raised to c by m. So c is your 15 divided by m into t is your 9 minus 35 is equal to 0. Right? So we'll, for easier purpose, we'll just m with x, so it will be easy for you to 15 into 9 minus 135 divided by m. So this is your f of x is equal to 0. Now you have to find the solution of it. So solution you have to find, and you have given the xl and xr value. So this is your f of x. So for iteration 1, xl is equal to what? 60. xr is equal to 70, right? So xl and xr is given x 60 and 70. So what do you do in Regula-Falsi? Regula-Falsi is x of I plus 1 is equal to XL minus FL into XL minus XR divided by FL minus FR. So you will require FL, FR, right? And then you will find XI plus 1. So therefore FL f of 60. So you will put the value of it here, 9.81 into 60 divided by 15 into 1 minus e raised to minus 135 divided by 60 minus 35. How much is it? 9.81 into 60 divided by 15 to 1 minus e raised to minus 135 divided by 60. So FL is equal to 0.1041. Similarly, FR, f of 70. So you will put 9.81 into 70 divided by 15, 1 minus e raised to minus 135 divided by 70 minus 35. What we will get? 4.1256. This is your FL and FR value. Now you have all the terms of this xi plus 1, right? So you can use that formula. X1 is equal to XL, right? 60 minus FL is 0.1041, XL 60 minus XR 70, FL is 0.1041 minus 4.1256. Therefore X1 is equal to 60 minus 0.1041 into 60 minus 70 divided by 0.1041 minus 4.6. 59.74, right? Therefore error E1 would be XL minus X1, 60 minus 59.74, or better we'll write 0.2589, right? Okay. Let me just Okay, therefore what will be the value? 2589. Okay, then what will be the, so this is, here you would have directly gone to the next one for this thing, secant method, but since we are in the Regula-Falsi, we have to compare the sign to keep it in the bracket. So therefore FL into F1 is, FL is what, FL is positive and F1, so we didn't find F1, right? So you have to find X1 we have found. So what is F1? $59.7411, sorry, 90, this. $9.81 into 59.7411 divided by 15, 1 minus e raised to minus 135 divided by 59.7411. So we are putting back into this function and getting its value. So how much it would be? Minus 2859.89. So this is negative. Therefore FL into F1 is negative, implies XR to be replaced with X1 for a next iteration. Correct? So you know the drill now, how to get, so you can find x2 with the, so we have already talked Excel, the Regula-Falsi, and this was just demonstration on the actual physical problem, how to get to this. So what we did is, we had given one description of the problem. From that we could see that all the equations have been, all the except the mass value, remaining values were given to us. So we could have write it down in the terms of f of m is equal to 0. You could continue with this, otherwise write in terms of x and solve it, and at the end you just back substitute, you just giving m is equal to x, so you just have a statement like that and you can get the answer. So after getting this equation, we have to take it into f of m is equal to 0 or f of x is equal to 0. So how we did that? We subtracted v from the both sides and we got this closed form solution equation. Okay, so and then we just substituted the values of given values and got the final function, and from final function in terms of m we solved it. So if you continue it for further iterations, you will get to the final value. So just wanted to show you few things. So I'll just switch back to Excel sheet so that I can talk further. Let's just go back to the Excel sheet. So we had talked about this, right? Secant I'll talk later. So if you see, we have done this iteration number 1, right? we got this value. Sorry. Okay. Saying something. You're not able to see the screen? You are not able to see the screen? Okay, let me just try it again. Is it visible now? Kanisham? Yeah. So what I was saying, we had done this iteration number 1, and got this error value. Since the this FL into Fi plus 1 is a negative, therefore XR would be replaced with the Xi plus 1 here, and the rest of the iteration would continue. Now if you see, even after 25 iteration, the error value is still 5%, okay, or 0.05. okay, we wanted 0.1% or 10 raised below 10 raised to minus 3. So if you see, even at the 126 iteration, it is going into the 10 raised to minus 2, and if you want to go 10 raised to minus 3, we might have to go till 1000th iteration. Yeah, right? Yeah, so if you see here somewhere, the error is going below 10 raised to minus 3. Yeah. So 2020, this is your final solution. So it depends, the increase is marginal here, right? So you could have stopped it earlier also. So this depends on the physics of your problem, understanding of your the problem. So 50.6 or 50.5 is a correct answer in this case, according to your this physics and this understanding of the problem. So now what will happen? We solved this using a Regula-Falsi method. In the case where if you would have tried to solve, so I would give you the task, try to solve it using secant method, okay? And if you, what will happen, can you tell me? So I'll just show you something so that so what was our equation? 9.8 into 9.8 into what? X divided by 15, right? 135 divided by x minus 35. If you see this is a discontinuous equation, and if you have given this, because of without a bracketing, the solution might not never found out. If you don't get, so actual solution lies somewhere at the infinity, or you can say this intersection here, this intersection somewhere here, right? So that is what your 50 is here. This is your actual solution here, this 50 somewhere here. So see, this 50 is your actual solution. But secant method, because there is this function is also there, so secant method what will do, if it goes near to this points or these points, it can tell you that the solution can be never be found, or it will go to the infinity. So if you find it using this thing, Excel sheet also, the error is also in Excel, using secant method here. So in I've written down the this spreadsheet for a secant method, and if you see, the error is going haphazard. It is reducing and increasing, reducing, increasing, reducing, increasing. So it is not a, so you should have a discretion. So here it is going in 10 raised to minus 2. Again it is increasing and going below 81,000%. So it is up to you to it is up on your discretion that which kind of a method that you are going to employ to solve it. Now, the bracketing method works well when there is a function which is having a discontinuity in it. So if you have a discontinuity, you should not use this secant method. You better try to stick with the bisection method. So that I wanted to convey to you all. You can try yourself the secant method. I will share this Excel sheet with you. Also, if you have the Chapran canal, if you can get it from online or something, it would be beneficial for you. So this problem, this I discussed, the last problem was from this Chapran canal 5.3, 5.13 I guess, Chapran canal exercise 5.13. So yeah, this is what I wanted to discuss for today. If you have any doubts, you can ask me now, otherwise we will wind up. Ganesham, if you have any doubts, do you have any? Did you understood what we went through today? So today it was nonlinear system of equations with the only single variable. We first started with the brief introduction. Okay, so you have one doubt apart from this. Okay, you can put it right now. Otherwise, if you want to send me, that is also fine. Then I can give you a better answer also. You can write it into the Google forum, or you can ask it right now. If it's related to Jacobi method, Regula-Falsi and Bisection method give converging solutions. Yeah, it always will give you some. You are using a this thing bracketing method, right? Secant method will work faster, but it might lead to inconvergence in the special cases. All are convergent methods. Secant method, so it depends on the function that you are considering. If the function is having a discontinuity, secant method might lead to the non-convergence. So you have to first see. So you can so by the seeing the error term, you can see that the error is haphazardly increasing. So you can see that okay, the function is not continuous. So from there also you can get an idea. Okay, this method should not work. I'll have to use the other method. Regula-Falsi and Bisection method will always converge. All the three converge, but this problem was a special case. So if you have gone through all the videos, at the last there is one video called some special cases in the module, this module 4. Just go through that video again, you will get the understanding. There is also this kind of thing. So if this is a 1, x square minus 1 is equal to 0, or this this is passing through. So this kind of a things where secant method might not give you the correct answer. Okay. Okay, I'll also check what I have given you. There might be a case, some other cases. I will talk, if there is something I find, I will discuss with you in the next class. So meanwhile, if you have any doubt, just post it on Google forum. Okay. Yeah. Thank you all. Thank you for listening. Good night.